Chapter 7, the official start of BC. It's area of a region between two curves. So let's say I got this green over here, and I wanted to find the area of the green. Well, I could post a grid and get an approximate, or I can think of this grid as a parabola and another parabola and get to find the area in between them. All right, I was off a little bit, but you get my point here, okay? So that's what we're talking about here, getting areas between graphs. So here we are. Objective. Students will be able to use integration, find the area between curves. Now, let's talk a little bit about area. If I have a graph that looks something like this, let's say I want to find the area between those two graphs. We'll call this graph F. You know what? Let's do different colors. I have colors here. I might as well use them, right? So let's do a couple of different colors. Let's call this F, and let's call this red one G. All area is measured to the x-axis. So if I wanted to look at F's area would be all of that. If I wanted to look at G's area will be all of this. So to get just what's left in between here, because it's all measured to the x-axis, what I'm going to do is I'm going to take F's area, and I'm now going to subtract. That was too big. All right, now I'm going to subtract. That's still humongous. Sorry. And I'm going to subtract G. So if I take F and subtract G, take away, just erase it, now I'm left with the area in between the two curves. So that's what we're looking at, folks, here. Okay? So let's do an example. That's all it is. So if you wanted a big formula, let's go back here. Here's the big formula. All right, you ready for the big one? It's going to be the integral of f of x minus g of x dx. Yes, that's it. Where f of x is the top graph and g of x is the bottom graph. That's it, folks. Something crazy? BC, all hard? No, this is what we got. So let's take a look at an example. We have g of x equals x and f of x equals 2 minus x squared. I don't know about you, but I'm not a big fan. I don't want to just keep graphing and graphing and graphing. So what I'm going to do is I'm going to find out where they meet, okay? To find out where they meet, you set them equal to each other. So you'll get 2 minus x squared equals x. And what I'll do is I'll get 0 is equal to x squared plus x minus 2. Factor this and find out that plus 2 and x minus 1, so they must meet at x equals negative 2 and x equals 1. Those are the points of intersection. They will become our limits of integration. Okay, these become the limits of integration, or the LOI. I know we had POI, these are LOIs. Now, we got to find out which graph is greater. Sometimes that's not so easy to see. So you know what? Take a number, plug it in. The number you get, the greater one, is the one that's on top. That's it. But you have to plug a number in between 1 and negative 2. Let's choose 0. But you can't choose a million. Million's out of the range of where they meet. Okay? So in between here is where they meet. I'll pick 0. So when I plug in 0 for G, and I'll do this in a different color, I'll do it in blue. When I plug in 0 for G, I get 0. When I plug in 0 for x here and f of x, I get 2. That guy's greater. So that's the one on top. So it's going to be f of x minus g of x dx. And now I'm going to plug and play here. So now I get, from negative 2 to 1, I'm going to get 2 minus x squared minus x. You might say, well, why did you put that in parentheses? If g of x was more than one thing, then we would have to subtract whatever's in there. So I'm going to finish this problem out. No problem. This becomes the integral from -2 to 1 of 2 minus x squared minus x dx. Now let's take the integral. To take the integral antiderivative, 2x minus x cubed over 3 minus x squared over 2, all evaluated at 1 and -2. When I evaluate it at 1, no calculators involved here, I get 2 minus a third minus a half. Minus, from the fundamental theorem of calculus, I'm going to put in -2. So I'm going to get -4 plus 8/3, and then minus 2 squared minus 2, I guess. Right? Because -2 squared is 4. 4 divided by 2 is 2. So when the smoke clears from this problem, I get 2 minus a third minus a half. Notice I didn't get any common denominators yet because I knew I had it on the other side. Plus 4 plus 8/3 minus, then it's plus 2, and it's minus 8/3 because I have to throw that negative out to all three. So now watch the magic happens. 2 and 2 is 4, and 4 is 8. -8/3 and -1/3 is, I don't know, -3, because it would be -9/3, which is 3. And then minus a half. So I get 5 minus a half. How's about 4.5? That is my area, and this would be square units. Whatever square units we have. That's our area between these two graphs, between 2 minus x squared and x. Okay? Let's continue. Let's do 2 more. I got 2 more here for you. I have cosine and sine. Do you really want to go and graph these and find out? Well, I have to tell you from where to where. So they cross each other, I think, more than once. So they're cyclic functions. So let's go 0 to 2 pi. All right? So which ones? Let's find out where they meet. Cosine of x equals sine x. The only time they're only equal twice, 2 places. They're equal at pi over 4, square root of 2 over 2. And they're equal at negative pi over 4. That's negative square root of 2 over 2. Okay? So our limits of integration, well, I got to choose something in between that. I choose 0. 0's in between that. The cosine of 0, 1. The cosine of this is 0, so cosine's on top. So it's going to be from negative pi over 4 to pi over 4, cosine x minus sine x. That's dx. And that becomes, well, the integral of cosine is, I believe, negative sine. I'm guessing. No, it's the other way around. The integral of cosine is sine of x, and the integral of negative sine of x is cosine of x, so that's what we got here. I hope I'm doing this right. Because sine would be negative cosine, but then the negatives cancel out. I think I'm good. I think you guys would help me if I wasn't. I may not be good. Who knows? So here we go. We're gonna do at square root of 2 over 2 is the sine of pi over 4. The cosine of pi over 4 is square root of 2 over 2. And I'm going to subtract when I put in negative. Well, when I put in a negative, is it negative pi over 4? Oh, wait a minute. They are negative. They are equal in the third quadrant. This guy's not in the third quadrant. The third quadrant is actually 1, 3, 5 pi over 4. My bad. Oh, shoot. Shoot. We got a problem. I screwed it up. There I go, screwing things up again. Okay. My bad. Sorry. I'm in a different spot right now. So now I cannot test 0. I am going to test pi over 2. My bad. Good thing I caught it. You guys would be angry if I did it. Cosine of pi over 2, 0. Sine is 1. Okay. So we're going to get from pi over 4 to 5 pi over 4. The only thing that's going to change is the sine and cosine. Sine of x minus cosine of x dx. Integration, I get negative cosine of x minus sine of x, all evaluated at 5 pi over 4 and pi over 4. So 5 pi over 4 would be negative square root of 2 over 2 for both of them. So that's actually square root of 2 over 2 plus square root of 2 over 2. Minus pi over 4 is going to be negative square roots of 2 over 2. It's negative from the fundamental theorem of calculus, negative square roots of 2 over 2, negative square roots of 2 over 2. So if I look at the area between these, voila! I think I have 4 square roots of 2 over 2's. I have 2, 1, 2, this would be 3, and 4. The negatives would go away. So I have 4 square roots of 2 over 2, which is 2 square roots of 2 square units. That's square units. That came out very messy. Sorry. And that's it. Sorry, I made a mistake before, but we recovered nicely. Okay, remember in the first quadrant and this quadrant is where they're equal, and that's where they would be equal. All right, last one. Here we go. Well, let's find out where they're equal. We have 3x cubed minus x squared minus 10x. And this one is going to be negative x squared plus 2x. So we have to, if we set these guys equal to each other, I'll subtract those and I'll get 3x cubed. Let me subtract minus 12x equals 0. Okay. And all right, and then we have factor out of 3x, and then we have x squared minus 4 equals 0. And now from here, we have 3x times x plus 2 times x minus 2 equals 0. 0. Oh, I can't get it. 0. There we go. Oh my God, we got a problem. Well, I don't know if it's a problem, but it's exciting maybe. 0, negative 2, and 2. This guy intersects at 3 points. They intersect each other at 3 points. So what I have to do is I have to look at negative 2, 0, and 2, and let's see which guy is on top, which one's on the bottom. All right? So if we take a point in between, we're going to have 2 integrals. We're going to have to get an area between these guys and an area between these guys. Let's choose negative 1. If I plug in negative 1 into this guy, I'm going to get negative 3 minus 1 is negative 4, and 10 is 6. If I plug in negative 1 into this guy, I'm going to clearly get something less than 6. So here, f of x is greater. Let's plug in 1 now. Let's plug in 1. If I plug in 1, I get 3 minus 1 minus 10. That's 3 minus 1 is 2. 2 minus 10 is negative 8. When I plug 1 in here, I get 1 and 2. I get 1. So g of x is the greater 1. So this is what our function's going to look like. It is going to say an integral. Whoa, an integral. No, it's not working. There it is. It lagged a little bit. I don't like where it is anyway. It doesn't like the green. I'm just kidding. I don't know. I don't know. Maybe it doesn't like the green. So it's going to be from the integral from negative 2 to 0. And now the f of x is the first function. So it's going to be 3x cubed minus, I think it was x squared, and then minus 10x. I think that's what was it. That's the f of x. Get out of there. Minus the g of x. So this is minus whatever that g of x was, which I think it was negative x squared plus 2x. So that's the g of x. Because the f of x was clearly larger in between here. Now I'm going to add whatever area I get there, I'm going to add 0 to 2. Got to be running out of time. 0 to 2. So the 0 to 2, I've got the g of x is first. and then minus the f of x.